Imagine waking up on a bright morning to see droplets of water on the leaves sparkling like tiny diamonds, reflecting the sunlight. Or perhaps a small insect walking on the surface of water, leaving you amazed at how it can move without sinking. These are just glimpses of the astonishing behavior of molecules in nature. Let's dive into the microscopic world and explore the fundamental structures of matter and the forces that shape them. Hello everyone and welcome back to the Axiom class. It's great to see you again. Let's dive in and start today's lesson. Everything begins with fundamental, ever-moving particles, atoms. Atoms are incredibly small, around 1 to a few angstroms in size and constantly in motion, exerting forces on each other. When these particles combine, they form matter, which can exist in different states: solid, liquid, gas, or plasma. In solids, molecules are arranged closely and in an orderly fashion, and strong intermolecular forces maintain their shape and volume. These molecules vibrate around their equilibrium positions, but are essentially incompressible. This explains why a block of ice resists deformation when an external force is applied. Crystalline solids like diamonds have highly ordered molecular structures, whereas amorphous solids like glass lack such order due to rapid cooling. Even in traditional arts, like metal engraving, materials are first soft and malleable and then hardened, a practical example of material principles in art. Liquids, unlike solids, have molecules that are farther apart, allowing the flow while maintaining a definite volume. Molecules can move relative to each other, which is why liquids take the shape of their containers. A simple example is how coffee mixes with milk in a cup. As molecules move randomly and distribute the substances throughout the liquid, gases are even more free-moving, with molecules spaced far apart and weak intermolecular forces. They have neither a fixed shape nor volume and are easily compressible. Filling a balloon with air demonstrates this, as it can be compressed readily, while water resists compression in a syringe because its molecules are closer together and repulsive forces prevent further compression. Plasma, the fourth state of matter, consists of electrons, ions, and neutral atoms, and it makes up over 99% of the observable universe. The sun is a prime example of plasma, producing enormous energy through electromagnetic and thermal interactions. Intermolecular forces play a key role in the behavior of matter. Cohesive forces, the attraction between similar molecules, allow liquids to resist compression to some extent. Adhesive forces, the attraction between dissimilar molecules, like water and glass, determine phenomena such as wettability. When adhesion dominates, liquids spread over a surface, whereas when cohesion dominates, they form droplets. Surface tension creates a thin, flexible skin at the surface of a liquid, holding surface molecules together. This phenomenon allows droplets to form spheres, insects to walk on water, and small objects to float on the surface. Capillary action is another phenomenon, resulting from the interplay of cohesive and adhesive forces, causing liquids to rise in narrow tubes. When adhesion dominates, water rises from the soil into plant roots. The height a liquid rises in a capillary tube depends on factors such as the tube's radius, surface tension, liquid density, and contact angle with the surface. Subscribe to our channel and stay tuned for upcoming videos to explore even more fascinating phenomena in the molecular and physical world.